So exam is coming up on Monday, and what's today? Okay, so we have arrays due on Friday. So what do you want me to talk about today? Something from this assignment on arrays? Something from exam? Which problem in arrays you want to talk about? Yeah.
Exercise 3. I had a question as to when writing test code.
Yeah.
Um,
Oh, the test code. Oh. I asked for write test. That's hard to do.
Yeah.
Yeah. That's
Basically, I just wrote a test code to. I filled in the array with just 1 through 100,
yeah.
and then I wrote one where I filled it all with zeros. It was kind of hard to come up with ways to fill the entire array
Yeah.
for different test cases.
Yeah, it's a little hard to write test code there. I'll show you one solution. Okay. So here's the function. Is all zeros. Yeah, I'll modify it a bit. Let's see. Is all zeros. Is no, I'll leave it like that. So let's write the test code first. We'll have a stub here. See what I'm doing is, this is not implementing the function. This is called a stub. And we call this, we'll do like assert. Is all zeros. And we'll pass in some array. But we don't really need that part, just like that. So we have an array, A, of size 50 and 100. That actually fills the whole array in with zeros. And so then when we call this assertion, this will pass, and then we'll print all tests passed, because we're returning true here. So now I'll change that to false. And see now our test code fails. Okay. So we implement this. We need to check that every item in this two-dimensional array is a zero. So we need to use a nested loop for that. So first we'll run through the rows. So I'll use a variable r for that purpose. And then we'll run through the columns. you see the rows are, there's 50 rows. That means there's a row 0, a row 1, a row 49, but there is no row 50. So we don't want R to hit 50. So R should be strictly less than 50. But we do want to start at 0, so we start with R equaling 0. So we've got a row value and a column value. So if we look at that, I'm sorry, we have a row index, a column index, I guess. Yeah, value is fine. If we look at the value in the array at that row and column, what is it that we're looking for here? We want to find a 0, right? So do we test for 0? If we find a 0, what do we do? Huh? We don't want to return true. If we find 1, 0, this statement finds 1, 0. Can we make a conclusion if we find 1, 0? No. They have to all be zeros. We can't just return true. We can't return true here if we find 1, 0. Well, let's try the other way around. How about if we don't find a 0? Can we return false? Yeah, because it's not all zeros. We found 1 non-zero. And if we run through this loop, this nested loop, and we don't return false, then we've checked everything. That means we didn't find a non-zero. Everything was a 0. So this does initialize everything to 0. In fact, I think this does not. But that's not, I'm not saying the test will fail, but if it does fail, that's convenient. It does fail, look at that. So we have no initialization, we're just declaring the array, and so the memory is just set to whatever random values that are found in that memory location at the time the array is allocated. We didn't do any initialization. But here we're saying that we want to initialize the array to, like this. So we could list out, 5,000 zeros. But that's too many zeros. So what happens is that the compiler generates code to copy that last value to everywhere. Let's test that. If I put a 1 there, this should be false, right? But what happens so what I'm saying is that the array is set to 2 zeros followed by 4,998 ones. But I might be wrong, so I want to check my assumption. So this slot here is a 1. In row 0, so this is laid out. This would be row 0, column 0 is a 0. Row 0, column 1 is a 0. Row 0, column 2, that's this one. Row 0, column 2 is a 1. But I believe that row 0, column 3, and 4, and 5, and so on will all be 1s as well. That's what I think. I never used this form of initialization before, but I remember reading it in the course notes, by the way. So let's test that. So this should still come up false. If I'm right, we should still find ones in there. I'm sorry, we got to set that to a 0. So let's zero out this one, and oh, this should be true. So if I'm right, we're going to zero out that one. Oh, I'm sorry. If I'm right, this will be false. But the rest of the array is all ones. Okay, so this confirms, if all tests are passed or printed now, it confirms my description of how that initialization works. And it doesn't. So this must be all zeros. So that must be zeros. So no, just it. Because I'm a little surprised here, right? A little bit surprised. I'm a bit surprised. So just to double check that, A03 should be 1. Should be 0 rather. So I'm wrong. That means the array only has one 1 in it, and it's filled with zeros. Okay, so if it just finishes the rest of the array with zeros, then this code should work. That should work, but these tests should pass. Let's see if that's true. It does pass. What happens if we did this? Let's turn the first element to a 1 and see that, in fact, the rest of the array is initialized to zeros. Let's see if that's the case. It is. So it'll initialize to zeros. Oh, look at this. What if we do that? That should give all zeros as well. Look at how much we're learning without reading the documentation. This is more fun than reading the documentation. Okay. Any other questions on this problem? You might want to use, when you submit, you might not want to submit the code that I'm showing you here. You'd want to test the other case. We set an item to -1. Now it's not all zeros anymore. Good. See, we want to at least test for the case where the function returns true and the function returns false. That would be a minimum. And that's good enough to do something like that. Anything else on this assignment or in the exam, sample exam problems? Nobody's looking at either you've looked at the sample exam problems and you have no trouble with them, or else you didn't look at them.
Can you just go over some command lines?
Huh?
Command lines.
Oh, the command line stuff, yeah, that's important. So if you look at this, here it is. Let me give you the answer to these. Show the Unix command to display your current location in the file system. PWD, print working directory. There it is. Notice we have the file system is organized as a hierarchical structure. So it's a tree. We have a root node, which is unnamed. That's that leading slash there, followed by folders under there, folders and files. And there's a folder called home. We can look at the other folders. These are all the folders that are inside the root. I do ls/. Just the slash by itself refers to the root folder. You know, the current folder is // which is dot, or or omit the argument altogether. But the root folder has got lots of these folders in it. This ls command has you can modify its behavior with some arguments, or options, they call them options. Like for instance, -l is the long form. I want the long form. And that shows us this is the owner. It's either a file or, these are all folders, by the way, because you can see the slash at the end. This is the owner of the folder, and this is the group that the folder is assigned to. So there's a group named root. So I'm running as root. I'm the root user, so I can read and write to anywhere in the file system. The non-root users are restricted. They can't write or read from certain places. You can change the folder. I can go to the home folder, which is represented by tilde, and I go to the home folder, pwd, print working directory. Well, now I'm in /home/Ubuntu. And inside this folder, I'm going to do ls. There's a live folder and a workspace folder. There's two subfolders in my home. So we normally work in the workspace folder, so I cd into the workspace folder. Now if I print working directory, I see that I'm in /home/Ubuntu/workspace. I'm in that folder called workspace, which is in, as you can see, the location of it in the file hierarchy. I said you could get to the home folder by cd tilde. Tilde represents the home folder, but cd with no argument by default puts you in your home folder. And inside this home folder, I'm going to go back into the workspace. I'm going to make a directory called temp. See that? I'm going to verify that it's there using the list command. There's temp. I'm going to copy main.cpp into the temp folder. There's the command for that. This also does the same thing. It doesn't overwrite temp. It actually puts the file, copy of the file in temp. So look in here, that main is still here, but if I do ls on temp, so ls takes an argument. It's the path to the folder you want to display the contents of. If you omit that, then the command assumes you want the contents of the current folder, the pwd folder. But if we want contents of a different folder, we provide a path to that folder. This is called a relative path because it doesn't start with a slash. If we started with a slash, it's an absolute path because we're starting from the root of the file system hierarchy. That's an absolute path. It starts with a slash, the root folder. I can get to that live folder going up to the parent And then, because my parent workspace, I'm currently in workspace. And my parent folder also has two folders in it. And it has a me workspace, and it has a lib folder, lib. I'll prove that to you. I'll do ls dot dot. So I want to see a listing of the contents of my parent. There's a lib folder and a workspace folder. Maybe I have a temp folder there. I want to remove the temp folder, or remove dir temp. Can't do it. Remove directory only works if the directory is empty. So we need to delete what's inside the temp folder. We only put one thing in there, main.cpp. I'll do rm for remove that file. Now if I remove the temp folder, we'll get it. Now it's gone. Let's make the temp folder back again. I'm going to copy main to a file called hi.cpp. I just made a copy right in the current directory. Now I'll move hi.cpp into the temp folder, mv for move. I'll do ls in the current folder. You can see there's main, but hi is not there anymore because it's moved into temp. Let's cd into temp and see hi in there. So mv doesn't move, but you can use mv for renaming as well. So I can move hi.cpp to by.cpp. So we moved it, we didn't move it out of its current folder, but we moved it in the sense of giving it a different name. Yeah.
Can I put the slash after temp?
We don't need it. It's optional. Yeah. We don't need the slash. I'll show you. I'll move by into the parent. Okay. If we look up in the parent, you'll see that by is up there. Actually, let's go up there. By is in there. So if we move by to temp, we don't need the slash. It'll work without the slash. Oops. I'll even take it off the ls command. See, I'm using command completion. So I go ls, I just press T, so then I press the tab key, and it just shoots it out there because there's only one thing in my current folder that starts with the letter T, and it's a folder called temp. And so when I hit the tab key, the command line interface will fill in the characters for me. And it adds a slash just as, because it's good, it's good information to show the user. You could see, oh, I'm in a folder. Temp is a folder. Well, you don't need the slash. If you were to type the whole thing out manually, maybe you wouldn't bother to type the slash. But if you're using the command completion feature, which is the tab key, then the command line interface will add the slash. Here's a dangerous command. Don't try this until you're confident. Remove dash recursive force temp. That means go into the temp folder and remove everything inside of there. And don't ask me if I should do it or not. Force it to kill it. Just go ahead and delete it. You don't want to do that. This is irretrievable. So you don't want to wipe out your home folder or anything like that. You're going to lose all your work that way. There's no trash bucket to pull deleted files out of. There's no undo. At the command line, there's no undo. If you want an undo, I don't know. Does this have an undo? Can I do an undo up there? Let me see. I'll do this. I'll do File, Delete. Right? How do I delete that thing? I have to right click, delete. Do you want to remove run? Yes. Oh, now let's undo. Edit. Is there an undo deletion? There's no undo. You know what? When you're working locally on your machine, there's usually an undo. But if you're at the command line in your machine, there's no undo. In Windows and Mac, there's no undo there. Linux, at the command line. Whoops, didn't need to do that. Clear. Make directory temp. Copy main. See, I hit the tab key there. It's just finished it. I typed an M and then tab key. T, tab key. So I copy main into temp. So temp has got something in it. So if I want to remove temp, it's not empty. So we need to remove the files that are in it. Let me put another file in temp. I'm going to put a file. I'm going to put by.cpp. You see, I'm copying main into temp, but also giving it a different name at the same time. So now we have by and main. See, you think of this copy command, there's two arguments, the source and the destination. And you can rename the file. You can specify the name of the copied file that you want in this destination. If you omit, if you just have a folder name there, it'll retain the same name for the file. All right, now what we want to do is say remove dir temp, which we can't do because it's not empty. So we're going to remove recursive temp. And I didn't put force in there, but it worked. Oh, okay, so I don't need a force. That deleted everything. You don't need the F anymore. How about this? Make directory temp. I can use the touch command, by the way. Say A, B. I'm just creating empty files with a touch command. There's two empty files, A and B. I just want to experiment. So I remove recursive, and I think Y is to like prompt me yes or no. I think that's what I thought it was going to end up doing, but it didn't. Invalid option. So we can remove minus help. See that minus R, look at that, minus R is recursive. Remove directories and their contents recursively. Force, ignore non-existent files and arguments. Never prompt. How can I ask for prompt? Oh, prompt before removal is I. All right. So if I remove recursive minus I temp, descend into the directory. So it's going to ask me if it's okay to do things. I'm going to say yes. Remove regular file A, I'll say no. Remove B, I'll say yes. Remove the temp directory, I'll say no. So we removed to B. We'll try that one more time. Descend into the directory, yes. Remove the regular file, no. I just want to see what it does. Remove directory, yes. What's it going to do? I don't know. I'm just curious. Cannot remove. Okay. I always do RF. Maybe I don't have to do that anymore. So remove tent recursively. But once again, be careful. You don't want to recursively remove all the files in your home directory or from the root, because we're a root user in Cloud 9, so you don't want to, you could really wipe out your workspace. If you did that, you'd have to delete your workspace and then create a new one. And these are very disposable. This is a virtual machine, right? Or it's something like a virtual machine. It's a, they call it, I think it's a Docker container. So anyway, it's some kind of limited environment that makes it look like you're the only user in the system, but you're not. So those are pretty much all of the commands that you need to know for the exam. Anything else? There's a lot to practice on here. I never talked about this. Did people know how to do this? You got that? I can't imagine everybody knows how to do that. All right. You know the difference between the post increment and the pre-increment? That's the key there. So you have to say, did I cover this already?
No.
I did. Okay. I just want to say one more time that that the key to this class is practice. You've got to practice. You can't just listen to me or read. You've got to do it and come up with your own challenges even. That's the best way to do it. Just like me, I'm just inventing stuff here, right? I don't know what would happen. Does this work the way I think it works? And then I create a little test to verify or to discover something. I can't imagine doing it another way. To me, it would be less efficient and certainly less effective. It's like I'm going to read a book about how to play the guitar, or I'm just going to pick it up and start playing it. You know, who's going to do a better job playing the guitar? You know, when the day comes, they're going to give a concert. The person has only read the book about how to play guitar, or the person just picked it up without a lesson and just started to play with it, right? Who's going to sound better? So it's like that. It's an analogy for this. What does this do? This code here, let's walk through this. There's two variables, n and k. So we can keep track of what they are, n and k. Let's keep track of their state. When we run line 11, remember this, when main runs, it's going to do line 11, then it's going to do line 12, then it's going to do line 13. So when it does line 11, n is created and initialized to -1. Now what happens when it does line 12? Well, let's take a look. There's an assignment in there. But this assignment operation is the last thing that happens, because these operations have higher precedence. This increment and this multiplication, those are two operations that should be done first before the assignment operation is done. And we all know this intuitively. I don't think there's anybody in here who doesn't understand that. But I'm saying it because it helps to articulate that what's happening at that level. I mean, you're saying, I just think, oh, I'm saying something obvious, right? It is kind of obvious because that's how anyone would design the language. But it helps to think about it and see what it is that we feel is obvious here, because that's what's going on. Now, of these two operations, which one goes first? The increment or the multiplication?
The multiplication before the increment is passed. So it uses -1 first. and then
That's
the first.
true. In this case, the multiplication is done first. That's right. Because the post increment is delayed. That's right. Exactly. The post increment, you want to do that last. So n times minus 3 is 3. This minus 1 times minus 3, right, is 3. And then 3 is assigned to k. And then what do?
You increment it by 1.
Exactly. We increment n. So n becomes 0. Now line 12 is finished. Now we'll do line 13. This is different. We have a pre-increment here. So that's done first before anything else. So we're going to increment n, which is 1. So this expression evaluates to 1 now. And we multiply by 4. So what I have highlighted right there becomes 4. N doesn't become 4, okay? This expression becomes 4. The thing that I have highlighted becomes 4. No variable that we see that's named in this code becomes 4. So this expression, which is 4, is added to k, which is 3. So this larger expression becomes 7. No variable is modified, but the expression evaluates to 7. 7 is sent into the output stream. So we're going to print 7. No, it should print 7. Did I make a mistake?
The int main is still in the arrays form.
Int main is what?
Your int main still has the initialization of argc and args.
Oh yeah, this doesn't have any effect.
That doesn't change it?
Yeah, that doesn't matter. I thought you were going to say I made a mistake in my reasoning here. So I'm always just a little bit nervous, you know. I don't know if you caught me last time on Monday. I had made a mistake. Just saying, I kind of covered it up a little fast. I wasn't totally honest with you.
We all talked about it after class.
Oh, you did? Okay. I figured that. All right. So here we go. There it is, 7 right there. We didn't do a good job at formatting the output, but we got the answer. So that's how you do that one. So this exercise has to do with distinguishing between these two operations. Yeah.
This is gonna be a paper exam, right?
Yeah. Yep. Paper exam. So it's a closed book, no notes, right? Okay. What about this one? Does everyone know what that prints? What does that print? Everyone should just figure it out in your head right now. Let me give you a hint. That symbol, huh?
Integer division?
That's integer division. And that
Floating point.
floating point division is 2 different operations with the same symbol. Because we have in the denominator, we have a floating point value in the second division. So that becomes floating point division. So what's the value of that expression?
0.
0, exactly. Because it's an integer division. We're not rounding. Of course, even if we did round, it would go to 0, right? So what would 2/3 be? 0. Yeah, we're not rounding. And this gives us 0.3333 like that. So that's what we get, 0.333. I don't know how many 3s are printed. Yeah.
And if we have 3.5, there's gonna be transient, right?
3.5?
Yeah, if we have 1 divided by 3.5.
1 divided by 3.5? Well, I wouldn't give such a hard problem on the test. Because I don't care if you can do, division like that. I just want to make sure you understand that that's floating point division. That's all. Yeah. You're not on the test. You're not allowed to use a calculator. But if you have a calculation that you're not sure about, just raise your hand and I will check it for you. Okay. So don't worry about checking calculations. It's very simple calculations. Like this one here. Here you need to do a calculation. What does this print? Look at this. What does that code print? Can you figure that out? Did you practice this yet? I hope, this is like the last day. I would have hoped you, practiced before coming to today, the questions, but, everybody's busy. Sure.
904?
Huh?
904?
Sounds right.
Because you're running the loop 300 times.
Exactly, running the loop 300 times.
And you're adding 3 each time, so 300 by 3, and then you add the
Yep.
initialized I.
That's it. You're adding 300 3s to I. But I starts at 4.
Oh, I see.
Huh?
Yeah.
Yeah. So you're starting at 4, and you're adding 300 3s to it, which is 900. So it's 904. That's good. Now that's pretty straightforward. The purpose of that exercise is to check that you know how to read code. That you can do some basic analysis on the code.
For these,
Yeah.
plus k. Does it matter if it's plus k or k plus?
No, it doesn't matter. K++ gives the same result. Because this operation, which is like the end of loop operation, it just stands by itself. So it's not used in any other expression. How about this one? Write code that determines whether n is prime. The program should print prime when n is prime and not prime when n is not prime. Suppose that n is an integer greater than 1. Now when I write it like this, suppose that an integer is greater than 1. Let me suppose there's an integer n, right? So we have an n. So I'm giving you n. Write code. You don't need to write main and all that stuff in there, okay, or function. Just write code that determines whether this n that's given to you is prime or not. Print prime or not prime, as the case may be, right? So basically just start coding it out there. Well, it's not really going to look like that, is it? So we're going to try all the divisors between 2 and n minus 1. If you find a divisor, then it's not prime. Oh, that means inside the loop, we're going to print not prime. And outside the loop, that means we went through the loop and we didn't find any divisor, so it must be prime. And if we do print not prime, we better exit, or I'll say return. Yeah, the problem's a little tricky, actually. It's a little hard to understand the problem. So, you know, if there's a divisor, if I divides n, then we're going to print not prime and we're done. Otherwise, we'll print prime. But, you know, the use of return there is a little tricky. So we could have done it this other way. So we'll do, you know, we'll define is prime, set it to true. Here's the alternative way to do it. And then we'll break here. I'm leaving the semicolon out there, you know. So, you know, in the exam, you don't have to worry about that. So this code well, we want to go up to n minus 1. If I divides n, then it's not false. You see, we set the variable is prime to true. So we're going to assume that the number n is prime. But oh, when we find a divisor, we change our minds. We say is prime is false. And then we break from the loop. You could leave that out. If you omit that, it's all right, because you keep trying the other divisors, it's all right. In the exam, if you leave that out, I won't mind. I mean, look, the whole thing's very inefficient. This actually should be square root of n. I mean, not should be, but that's sufficient, and then I'll run a lot faster. But I'm not looking for that. I just want to see that you can craft, remember this much of it, you know, this simple form of the solution. So, and I'll put that in there because that makes sense to me. Or you could do it, you know, you could do it this way, or you could do it the way I showed up here with a return statement. Although I didn't say you were inside of a function, where the code was. I didn't say the code was inside, to be put inside a function that you shouldn't return from. So in that case, this would be a better solution here. But this is simple. This is acceptable to do this. Now that I think about it, this code here, an easier question would be implement a function named is prime that returns true if the number passed into it is prime.
Isn't that 14?
Is that 14? Yeah, there it is. This one's easier to do.
Can we go over that one? I'm
Well,
still confused as to how you use the function boolean.
Oh, well, that would just be, you know, this, it's just this code right here. Is prime. It's just this code right here. And this is, so we're returning a bool. And so we have to return false here. We don't need to see out anymore. See, this is a lot easier to do. But on the exam, you only need to show me that right there. That's what I have highlighted. That's sufficient. Oh, but you don't want to write I divides n. You want to, if n mod I is 0, that's what you need to write there. N mod I is 0. Same down here. This is n mod I. So we want to try to divide n by I, and if it gives a remainder of 0, it means I evenly divides n. N can't be prime. There we go. So there's the solution right there to number 14. We want to know if n is prime. Oh. We don't start at 0, we start at 2.
Then 1 would make it equal 0, right?
If it's 1,
It would one always divide.
I'm not going to worry about 1. Let's say it again.
I said 1 will always return 0, wouldn't it?
If we pass in 1, well, I mean, I don't know what, in math, I don't think in math, do you consider, I mean, n, that's like philosophical or something, is 1 prime or not? It's not prime.
I think the least prime is 2. That's why the definition of prime has to be greater than 1 strictly.
Yeah, so 1 is an invalid input to the function. So we're not going to worry about 1. Just like we wouldn't worry about minus 3. We're not going to accept a negative number either. So we're not worried about 1. So 2 would be the largest number, the smallest number. If we wanted to, you could put an assertion in there. Just to make sure that the programmer doesn't pass in a 1 or a 0 or a negative number.
What if somebody types in a letter?
Well, it's not a matter of typing in because this is an argument to a function. So the code won't compile if some other part of the code tries to pass in a character into an integer argument. So it won't even compile. I get this feeling people, they're not ready for the exam. Yeah.
How about number 4?
Number 4? When the code in figure 4 runs, which is this one right here, what does it print? What does it print? Let me put it over here. What does this code print? Well, there's only one variable to keep track of, I. So you just walk through it. Look at the first one. See, I is set to 5. So I'm just going to make a note there. It could be a mental note, or you can write it on your paper. I is 5. So we just finished this statement, 4, line 4. Now let's do the while loop, which is a statement unto itself. After we do the while loop, then we do the cout. Okay, so the while loop probably modifies I, and that's what we're going to end up printing. So let's look at the loop. The loop has a loop condition. So we're going to repeat that line as long as the loop condition is true. I greater than 0. So I is 5. 5 is greater than 0. So we'll do this. We'll subtract 2 from 5. So 5 minus 2 is 3. And we assign 3 into I. So now I, we're going to change our mental note, or our written note, of what I equals. It now equals 3. And then we check the loop condition. The loop condition is still true, so we subtract 2 again. I goes to 1, check the loop condition. The loop condition is still true. I subtract 2. So I goes to -1. Now check the loop condition. The loop condition is now false. So we have completed the while loop. And now we do the statement in line 8. We print I. So we print -1. Okay. Now, at home, after you do that, you might as well test it, right? So, we worked it out at home and on paper, which is what we need to do for training purposes. But we don't know I didn't give the answer, right? So that means you got to code it up. And which is not hard to do, and it's also good practice. And -1, there it is. You see it down there. Maybe when you code it up for testing, I just didn't want to. I wanted you to see less in the exam, so I didn't put that in there. Here we go, -1. Easier to see. All right.
Can you go over printing random numbers?
Printing random numbers? Yeah. So let's look at printing random numbers. So when we deal with random numbers, we want to initialize the random number generator to a seed value that's based on time. Was that in C standard lib? Or is it C time? I can't remember. You won't need to know this for the exam. None of that you need to do on the exam. And I've highlighted there. You don't need to write that on the exam. So once we see the random number generator, we can start printing random numbers. There's a random number. There's a random number. A pseudo-random number. And, we can make that into a loop. Let's print 4 random numbers. Four random numbers, there it is. Now maybe these random numbers are too big. We want 4 random numbers that are, less than 100. So we want to use the modulo operator. So we'll divide by 100 and take the remainder. The remainder has to be less than 100. That's why we use the modulo operator here. So that gives us random numbers, 0 to 99 inclusive. There it is. Looks good. Trying to do it faster than 1 second, but I can't do it. All right, so because that seed will be the same, right, if it's the same second. What about, we want random numbers between some range, right, from, say we want 4 random numbers in, 4, 11. Well, let's see, what's the range? The range is, let's see, it's 4, 5, 6, 7, 8, 9, 10, 11. Counted it out with my fingers. 8. So well, I'm just figuring that out in my head here. It's got to be 8. Because I want 0 to 7, and I'll start at 4. So the smallest number should be 4. So rand can return a 0. Rand mod 8 can return a 0. So that'll give us a 4. That's the lower number in the range. The highest possible value we get from rand mod 8 is a 7. It's the highest possible value. So in the case that it evaluates a 7, we'll get 4 plus 7, which is 11. So that hits the number in the upper part of the range. So I'm good. Look at all those 11s. That was strange. Let's see. No more 11s. All right. So that's about it. Oh yeah, then the how about like floating point numbers? If it's between if these are floating point numbers, then it's a little different. If we want a floating point number, then we take rand and divide by rand max. I think I used int max, right? But rand max is a better number to use. I don't know if rand returns all the way up to int max. So the purpose of rand max is to specify the largest number that rand returns. So rand max is a better number. I think that's in C limits. I'll just put it there. Once again, you don't need to remember C limits for the exam. So this will give us a number between 0 and 1. This is an integer, and this is dividing by the largest possible integer it could ever be. That will always give us at most a 1. And what are we getting? Oh, what's the problem?
Need to cast rand as a number.
Yeah, this is integer division. This is integer division. So we need to tell it we want floating point division. So let's just turn rand max into a double. By the way, if you leave that out on the exam, I wouldn't take any points off. Right? That's like a little detail for me. Okay, so that's better. There we go. But if we want it to be in a range, then we've got the start of the range. Let's say it's a plus the random value between 0 and 1 times how long the range is, b minus a. So that'll generate a number between a and b. Of course, we need to have that a and b defined. So a is, say, 3.5, and b is 8.7, say. Yeah, so it's less than 9, it's less than 8.7, but it's bigger than 3.5. Let's see if we can get a 3. Look at that, all those 7s. I'm not getting a 3. There's a 3. Thought something might be wrong. Okay. So that's the random numbers. That's all you need to know for that. Anything else? What time is it? That's it, right? So that's it. We've focused on preparing for the exam. Yeah, another question?
I just want to make sure, like, if we run number, I mean, if we run the number 3, is the output going to be 92? Just want to make sure.
If we run the number 3?
Yeah,
What do
and
you mean?
exam 1. Exercise 1.
Exercise 1?
Yeah. No, exercise 3.
Well, exercise 3.
Yeah, so if we
Oh, I'm sorry, this one here?
Yeah, this one.
What's the answer to this one?
92.
92? Does anybody agree with that? I didn't look at it yet, so I don't know.
Just want to make sure.
Well, see, the loop runs 40 times.
So it's 40 times 3, right?
40 times 3
No,
is
no, then it's
120.
120 plus 10 is 130 plus 132.
132.
Right.
132. That's the answer.
Okay.
See, you look at the loop. See the body of the loop? This does not affect I.
Yeah.
So in the loop, we just increment I. So look, we start I equals 0, and we go to I equal 40. We exit when I it's 40, so it's going to be, the loop will run exactly 40 times. You know, when you see a while loop, usually the loop condition has a variable that's modified in the body of the loop. But in a for loop, that's kind of goes against readability concerns. With a for loop, the variable that you use to control the loop is independent. Good programming practice would make that variable independent of what's going on in the body of the loop. You can use the I inside the body of the loop, but don't modify it. If we're going to modify I in the body of the loop, and I is used to control the loop through the loop condition, then use a while loop. That would be what would be normally expected by people reading your code. So when you see a for loop, you're going to say, well, all right, it's going to run so many times. I can ignore what's in here and let me just stare at this for loop for a minute before I look anywhere else. And how many times does the loop run? Well, so it starts at 0, stops at 40, runs 40 times. Okay, so the loop runs 40 times. All right, now what does it do in 40 times? Adds a 3. That's 43s. Or, right? 43s. So that's 120. But we started at 10. So it's going to be 130.
And then plus 2.
And plus 2 there.
132.
What's the value of n after this line runs? Suppose we print n as the very next line. What do we print?
10.
130.
130?
130.
Really?
Yeah.
Thought if it was inside the braces, it was a local. Or
No. We add 120 to n in here. This expression is what we print. We're not printing n. We're taking what n is, which is 130. Adding 2 to get 132. That's the value of the expression, which goes to C out. And n remains at 130. See, that's one of those little, just a typical mental problem people make. That's why I asked it. Yeah.
How do you know to multiply by 3?
How do I know
To multiply by 3, 40 times 3?
2? I couldn't quite get the question again. How do I know
Why do we multiply by 3?
by 3? Because we do this 40 times. We're adding 3 40 times. We're adding 43s. So, 1 3 is 3, 2 3s is 6, 3 3s is 9, and 4 3s is 12, 43s is 120. That's why we multiply. You got it? Sort of. You got to think about it. You got to work with it. You got to practice. If you don't practice, you're not going to get it. Yeah.
So it would be like 40 times 3, 120 plus 10, so it'll be 130. And then this CI will be 132.
Say it one more time.
Like the C out, would it be 132?
Yeah.
Okay, I see.
Yeah. What is n? 130. And then we add 2 to get 132. That's the value of the expression. We're not printing n. We're printing n plus 2. So we print 132. But n was and remains 130. Three minutes to go.
What is the difference between for loop and while loop?
Well, I just talked about it, but let me repeat that the for loop is that, like, usually they're both equivalent, by the way. You can always convert one to the other. But the for loop is where the loop condition is independent of the body of the loop. So here, you know, we want I, the loop condition depends on I, and we're just going to increment I because we want to do something 40 times. So we use a for loop. But if the code had, like here, see this while loop there? The loop condition depends on the variable I, but I is actually modified inside the body of the loop. So it's a better, you know, let's use a while loop for that. Yeah.
We don't give solutions, so you can compare, like if you can't get the question, you have nothing to compare to.
No, you code it up. I showed you how to do that. We just, you know, we just did that right here. We just popped the code right in there and saw the answer. That's it. So I did that on purpose because you need practice. All right, I think that's it. Okay, good luck on Monday.